In section 5.5 and 5.3, we'll be writing equations of parallel and perpendicular lines from point-slope form. So first, I thought it'd be a good idea to derive what point-slope form comes from. And so if you notice, I have the slope formula here. And back from chapter 3, we learned about how proportions could be solved by cross-multiplying. So 1 times anything is just that thing. And m times this quantity. Do you remember how you have to put parentheses around this? Because it is a binomial. The reason why it didn't matter here is because it's 1 times anything is just that thing. So that's where point-slope format comes from. You'll notice that in the book, you won't use the 2's anymore. It gets really confusing with all the subscripts. So the other prerequisite knowledge that you need to know, for example, if the slope is 5, the opposite of 5 would be negative 5. We get that from looking at a number line. The sign changes to its opposite. But the reciprocal of 5, since 5 is 5 over 1, the reciprocal would sort of be the flip of that number. That would be 1/5. And if you were both the opposite and the reciprocal, you would notice that a positive number would change to a negative, and the number 5 over 1 would flip to 1 over 5. The importance of understanding the concept of opposite reciprocal is truly important, because if two lines have opposite reciprocal slopes, those will be perpendicular slopes. Whoops. And if the slopes were the same number, like m equals 5 and m equals 5, those would be parallel lines, parallel slopes. So, some people would rather say that it's parallel lines because the slopes are the same, and perpendicular lines because the slopes are opposite reciprocal. As long as you understand those major vocabulary phrases, you should be in good shape. So what you're going to learn in this section is that we're going to be given or be able to calculate a slope and given some kind of point. So for example, 1, 3, and we're going to plug into this formula the m for m, the x for x, 1 actually. Let me go back and circle the m, and the y for y1. But watch your signs. You want to make sure you bring down the y, you bring down the minus, you bring down the equal, you bring down the parentheses, and everything else. So this would be an equation of a line containing the point 1, 3 and the slope of the line 1/2. If you distributed, you could also get it into an equivalent slope-intercept form or an equivalent standard form. And you could check out other videos to see how to do that. Good luck in this section.